Our first speaker is Chihae Yang, who is representing Altamira and Molecular Networks today. And Chihae has been in charge of organizing the database and, as you'll learn later, about the threshold of toxicological concern. And when we started the project, as I said in one of my first slides, really this area was very undeveloped in terms of alternatives. If we're going to develop models, then one of the key aspects is we require data. And the databases, particularly of repeat dose type toxicity data, were very poor 5 years ago, not only in terms of the data they contained, how they were storing it, but also the technology. So one of the key outputs from Cosmos has been the development of the open Cosmos database. One of the things we must ensure, and I'll try and wrap this up at the end, is our legacy and where we're going. So whilst the project ends at the end of this year, one of the questions you should be asking us is, if you see something useful, how are you going to maintain that? So Cosmos database, we're very much entering into a spirit that this will continue. It will continue in its form, and we'll also continue, and I think Chihae may tell us a little more about this, or we can discuss it, in a form where we can use this as a forum to share data, to compile data, and to allow users better access to data. That's a really interesting, exciting to me aspect of this wonderful database technology. And I must admit, 5 years ago, 6 years ago, when we wrote the proposal, I didn't know anything about it. I thought a database was an Excel file, as I used to say to Chihae. And I now know it's something very different. It's structured, where we record information, and it's vital to do what we're doing, to have the informatics right at the start, but also vital to plan what you want to store in the database. And those are some of the key learnings I've had. So is that a suitable build-up for you, Chihae? I'm going to pass over now to Chihae Yang from Altamira Molecular Networks, and she's going to tell us about the Cosmos database, where we are and how it is.
So I always like to start out with the time era, where we're going. So we started, and the first thing I want to tell you about, within this year, the first years of few years, we released what we call Cosmos GB1. Then, from the conception of the project, and this is where we are, and I'd like to actually to think with you, this is what we have and where we are going. The first thing I'd like to tell you is where we came from, is a brief history. One of our partners, USFDA CIFSEN, and some of us, like Altamira and Molecular Networks, have worked with them for long years, and we built their database, what they call CERES. The CERES meaning this is chemical evaluation and risk estimation system of their office. And in their office, of course, in addition to their food additives, they have all the interesting compounds that known and all associated with the toxicity studies. So like I said, I'm going to throw a lot of numbers, which means that we're just going to skip those things because I want you to have a concept. There are a lot of huge number of compounds and structures in that database that anything public content was donated to our Cosmos, and the data are related to the colorant and food additives related substances. Initially, the structures, some of those structures we actually were getting from USS, the DSS talk. The PNG, our big donator, they actually donated 35,000 structures in the upfront, so that it's an SD file, so that we could actually move ahead. And Cosmos partners also participated. This is the chemistry part. The toxicity part, they donated what they call the legacy database, PAFA, which is the priority assessment of the food additives. And they have many substances, over 1,000 substances and 27 types of study types. And in fact, there was an oral toxicity of about 1,000 compounds, and I'm going to go into a little more details later, slowly peeling the skin. And then there's also acute toxicity and genetic toxicity data. So when you look at this thing, it looks like this database had a data from genetic toxicity to the carcinogenicity to the acute tox, to all the repeat dose. So what does it look like? Somebody was trying to do hazard identification in that office using this, and that's how it was used. So based on that, we are then starting to add our additions. So the version 1 chemistry, we already had various public content of the chemistry. What we added was cosmetic inventory. So this I'd like to talk to you a little bit more in detail. Then we added repeat tox TB. So repeat those toxicity database that we actually harvested. So I'll tell you this a little bit more in detail. So if you could look at this is a famous Cosmos view, and you probably noticed where it came from. The same design that we put together from Ceres to Cosmos. We just changed the goddess of the harvest, Ceres, to the cosmos flower. Then, so these two are now in public V1, or this is a public production instance. What we also have internally, the Cosmos only had DES, meaning data entry system, that we shared together the data entry, and we did a QC on it together as a group. So it was used for those. And then we are actually adding our Cosmos database, the TTC database. We are testing those things out. And then this is the home for the next skin permeability data. So there are two different types of Cosmos database. One was the production one, the other one was the data entry. So like I said, I would like to actually take a couple slides with you about the cosmetic inventory. Why this is important. From the beginning, there was a need that we didn't know what it meant by cosmetics ingredient. The people who are working in the cosmetics industry, they know by looking at this because they use it. For us, modelers and chemists and other types of related industry people, we don't know what constitutes a cosmetics chemical or ingredients or related chemicals or what's in the formulation. So it was very important for us to have a lookup table. So that's what this was. We put together a lookup table, recognizing that there are two known sources for cosmetics ingredients and related chemicals that has been used for formulation of the cosmetics. One is a coding, the EU coding. The other one is the Personal Care Product Council in U.S. And this is about 19,390 INCI names. And why are there not the equivalent number of CAS? This is the whole story, that many of them are not having a registered entry IDs, or there are many, many botanical. And so putting that together was quite difficult. And what exactly, this in between, there's about 3,000 overlap, but there are more. So while we're actually peeling this very difficult multi-layer problem, the PCPC part in the first cosmetics inventory version 1. So if you ever download cosmetic inventory version 1, that would have been the one that we put together based on the John Bailey's book of what this called the book on the cosmetics. There are about 4,000 compounds listed with the CAS well defined. But that's not really what PCPC actually has in their database. So what PCPC have done for us, this is again was arranged by our scientific advisor, Susan Felter at P&G, has arranged it for us, that we had an access to PCPC ingredient database for a few months, so that at least we could take a look at it and see what was there and what our problem is, how could we actually resolve this. Okay? So remember that. We used to actually learn about this. So we had a time-limited access, and it explained the problems of the difference in the John Bailey's book and their PCPC list. The solution was our collaboration began with the USCIR, the Cosmetics Ingredients Review, and this group then actually now, this is a voluntary reporting of the cosmetics program in US FDA. They received this list from US FDA, and the CIR actually regularly passed on to us so that we could update it. So you can see how the progress has been made, and I'm just showing you. Here's a zinc PTO, and here's the connection to the coding and SEC opinions. Here's the INCI name. Then here's the coding chemical function. Yes, this is anti-dandruff and the hair conditioning, and all this the chemical functions we're using. And if you click on it, you could actually get to it. One thing that we find it important is that why was this chemical understanding of the chemical space was important. The cosmetics inventory was really put together as a lookup table, but also as the chemical space understanding. So we're comparing different compound classes, which I call the chemotypes, representing this database. Then this blue is the cosmetics, and the green is the food. So why am I comparing food and the cosmetics? There's an interesting thing that this is my favorite thing to say. A woman eats lipsticks, a kilogram of lipsticks in our lifetime. So what we put in our mouth, what we put in our face, It could also go into the orally. So the chemical space is very, very close. There's a difference. For example, we don't eat surfactants, and they show up very nicely in a different part of the chemical space. So these things this is why it was important to put together a cosmetic inventory, understanding the chemical classes. The next thing we're doing is, okay, I have a cosmetics inventory. We also have quite a bit of, good or bad, some toxicity study. So I'm not going to go into quality yet. I'm just going to stay very up high and say, okay, how many compounds do I have toxicity data? Of those 19,000 INCI names, this shows us the need for data. Of those 19,000 INCI names, I was able to find about 800 compounds with some data. Okay, so there's about 1,000 in vivo toxicity studies, and when I'm doing this, I am not including short-term. So we're including the oral toxicity. And look at this. Here we go. Here's the rat and subchronic. That's the highest in studies. We're looking at whether it's a dog, monkey, or mouse, or rat, or rabbit, and this is the chronic, subchronic, and reproductive. Okay. So most studies are done on the rat with the subchronic. And why is this thing important? I'll get to it later on. There's a relation. Okay, then we also look at target organ. What are these chemicals found, or cosmetics-related chemicals we found in the cosmetic inventory? What are they hitting? They're not very different from others. They hit liver, kidney, GI, reproductive organs, endocrines, and spleen. So this is the order. I'll actually come back to that and remind you of that order. Now, then, are they really a potent chemical? They're not really very potent chemicals. So I look at, here's chronic, here's the median, and then here's the mean. And about 30% of these 296 chemicals, they have Noel values over 500, which we consider, well, maybe not a critically urgent to look at the toxicity data immediately. Subchronic, look at this one, about 20%. Remember subchronic rat was the highest. We had most data, and it also has the Noel values lower than, so it's means also low, medians also low, and reproductive about the same as subchronic. So we're beginning to just kind of peel the skins away, and at this point we realized we don't have good enough data. Many of this data do not have really dose level effects so that we could actually go to mechanistic studies or can be useful in guiding us. And another thing that was important for us is that level of information was needed to support TTC and reader cross and all the other things that scientifically we are doing. So at this point, Mark and I actually just decided we were just going to form a harvesting group. So it was established in Columbus and Mark and his camp, because I couldn't travel and live here. So manual curation went on, and we were concentrating on regulatory-related data like SCCS. However, we actually went for the original publications whenever it's possible, unless it is a study report. So we have about 230 test chemicals. Of this, 186 is really from SCCS and cosmetics-related ones. We know for sure these are cosmetics-interested chemicals, and about 100 of them are hair dyes. So I had very interesting discussion about this because of TTC. Then there are also U.S. FDA CIF10. OFAS is our food additive safety office, which they deal with the packaging. The packaging material, although it's different from the food and the cosmetics, because cosmetics tend to use the more pretty ones, they're different. However, the impurities are also important, so we took the impurities, even if it's not a cosmetics-related chemicals in the cosmetics inventory. Then all these 300 toxicity studies we harvested, these are the sources, and including literature, and went into what we call all repeat tox database. And that is actually right now available through version 1. So this Multigon is where we define what studies are we going to actually include. This is one of the most important things for a database and to be used for the scientific reasons. So first of all, has to be oral study. That's the queen or king in the center. Then we look for certain study types. These are the study types we look for. In carcinogenicity case, chronic carcinogenicity, those combined ones too, we did not include neoplastic lesions or neoplasms or neoplastic findings unless the compound is really genotoxic that we have to really consider differently. Then that was separated out. Now, this must meet the species requirement, then dose and the regimen requirement, how many dose levels. We don't take single dose, and we actually mark very clearly how many days. It is a 5 days gavage study, 7-day gavage study, because SCCS they like to adjust their dose level for that. Then we go into the effect findings for the dose group. This was a very important thing because without the effects, we can't do any modeling. Duration, of course, comes with the study, and we took only any experiments greater than or equal to 28 days. So we did not take 14-day studies. One of the important things, this very important thing for me personally, it's really a pain when you cannot find that article and when there's a typo, so you can't find them. So this is where we spend a lot of time. We like to be transparent. Okay, so this is just a screenshot which Christof will go. What I wanted to show you, he will go in detail, is that now this time I could proudly show you that we have something to look at. Okay, this is a passion I have. Here's my dose level, here's my assay, body weight, clinical signs, and organ weight. Okay, and if it's going to be no change, tell me it's no change. Don't just not report, because I would not know. So no change is reported, increases, and is it treatment related, dose related, is it statistically significant or not, and if you have a comment or complaint, write it. So that's how our database is. Okay, so the next thing is, once you have data, you can have all the fun. And this is my best fun. So please understand if I play with numbers, because you might go fall asleep, but this is really what leads you to, oh, this is exciting. Okay, again, remember rat subchronic from the big PAPA data that was only high level. We're going to see the same thing. Here we go, rat subchronic. There must be a reason why they test rat subchronic. Sensitivity-wise, I learned that later on, but toxicologists don't do just experiments for no good reason. They do reason. They have good reasons. Now, so I'm start showing you something very simple, a systemic effect. Let's think as body weight changes, okay? Are there going to be any differences? It could be body weight gain, it could be absolute body weight. Anyway, so you've seen that how we actually mark it, decrease or not decrease. Because of that, I could say no change, increase and decrease. Look at this. Here's chronic, and here's rat, here's dog in the back, subchronic. So it looks like I don't think I'm going to eat that thing. It's going to increase my body weight. Overall, in this oral repeat talks, we have 36 organs in the systems and listed. This is in the order of that. Remember, we had liver, kidney, reproductive organs, right? Spleen and endocrine. You look at this thing, right? Again, rat liver, rat kidney, they're just like firecrackers. And same thing, stomach. This is a GI system, spleen, lung, in that order. What's different about it this time is that I could get down to the cell level, okay, which will actually lead to the mechanism, and then I could do something about it later on. Okay, so I'm looking at this mesenchymal Kupffer cells. This is a liver. How many cases do I see that? Parenchyma in general, or coming down, if I have central lobar hepatocytes, how many of them are affected? So now I'm really coming down to, I could describe this by organ system, segment, and tissue. This is very important. Actually, this control vocabulary was done by the veterinary students and cells and organelles, and help with help from a Vasilicheva, a toxicologist. So you have to love this data. I'm coming down to this. This is now all that you can look at it and see there is something in there. We found about 60 compounds that have this effects in the liver. Fatty changes, fibrosis, lipid depositions, inflammation, hepatitis. And not only I have this, we would know where it happened, okay, and how often it happens. So now that leads to our phenotypes of steatosis and steatohepatitis and fibrosis. This is how we get into, okay. So now, from my liver, I was able to find these things. I'm all in the tox area now. How many of us are chemists? What happened to chemistry? Did I lose that? I didn't. This is the beautiful part. So we know most sensitive species is rat. The common organs are this, and here's the common liver findings with this type of cosmetic-related chemicals. I didn't say cosmetic ingredients. This is very important. These are the chemicals that we normally see. Here we are. Primary, secondary alcohols, choline, organohalides. Now I have 1,2-glycols. Look at this glycol, long chains now. So you have to, some of you already go, bingo, I know some of this. Okay, I'll come back later. Aldehydes and alpha beta saturated aldehydes and ketones, microacceptors, are there. I didn't make this one first. I made all the database first and then mined the liver data, and I came to this. So this is not fixed. This is really data. So you could imagine how happy I was when I saw that. On top of that, we sent a couple of this to Vanya's group because we were questioning, suspecting, is it related to PPAR gamma? So that's another story that Elena told you this morning. This process that I just showed you, this is why we're doing this thing. Databasing, when you do this thing, is very, very painful. You don't want to be near anybody who is parsing data into a database. I don't care whether it's an Excel sheet or real data, Oracle. It's painful. But when you start counting, the counting is no fun unless you have a database, really. And when you start making sense out of this, your findings happen, hepatocytes, well, it has this thing. Cooper cells, it has that thing. And start making sense. And then the chemistry is linked to that. Then all the pain we have paid before, that disappears. And this is what I wanted to say. This is where we are. Where are we going to go with this? So the future of the Cosmos DB, I'm going to show you where we are. We're still a little more work left. So as you know, version 1.0 has database searching, and some workflow I want to show you. We said we deliver it. It's in our contract, so we have to deliver this part. We are delivering that. This one is a TTC database. From here, so when I actually do the TTC, I'll actually show you what we do. You click a button, it'll generate TTC databases. Cosmos, Monroe, and on and on. And so this is the TTC part. There's another part we call DES I told you about, the data entry part. Here's the chemistry entry form, here's the toxicity entry form, and we have skin permeability entry form started. Now here, data entry, and then this is where actually people do QC together through the web-based system. And Cosmos Group, we actually have done that together before we released the Cosmos V1.0, what have we done? We did communal structure QC, work together through this. So I just want to tell you all these pieces of work, although when you do this one, it all look like, oh, there's so much and painful. Hopefully you have seen some of the joy of this. Thank you.
Thanks, Chihae. Are we going to see the database in action now? I think that's a great introduction. Our next speaker is Dr. Christof Schwab from Molecular Networks, and he'll be doing, you should see an online demonstration of the Cosmos database, and you should hear him describing it at the same time. If you can't hear him describing it, please do contact us through the chat.
Thank you. Thanks, Mark. Just one quick sentence to the technology behind the Cosmos database. So everything is web-based, and we also selected tools which we use to set up this database that are actually open or freely available. Thorsten already mentioned one chemistry toolkit like the RD kit, which has been donated by Novartis to the community. So for example, for every chemistry stuff, any chemistry awareness of the system, we are using this RD kit platform, but also for the database technology, everything is open and free technology. All right, so what I want to briefly show to you, and I already apologize for sitting down, but operating the mouse and typing is easier when I sit. What I briefly want to show to you is this part here, the database search. So you see the Cosmos system itself, it just runs in a web browser. Standard web browsers are supported like Internet Explorer or Firefox. And once you are logged in, you just click here on database search, and what you see now is basically the query form, the door to mine the Cosmos database, and Chihae has explained quite in detail what is available in the Cosmos database. And I have to apologize, the application has actually been developed for wider screen, so the resolution here. So basically you have two different forms, two different query forms. You have one form to define your chemistry search. A chemistry search could be that you simply search for the name of a chemical, or if you have the identifier, DSS Tox ID or the Cosmos ID, you can just search for Cosmos IDs. You can search for CAS registry numbers when you have that, but you can also import molecules. You can draw molecules with a small molecule editor. I will show that later on, or you can, for those who have things like that available, you can just copy paste, for example, a chemical representation like a smile string into the search form. On the right hand side, you have the part to define your toxicity queries. So here you basically, if you click on this panel, you start a tox query builder where, for example, you can select the various endpoints that are available and in which you are interested, or also the study sources you wanna data mine, things like species and strains you're interested. So everything is configurable in order to filter down, to narrow down your search. Let's just start for the demo with a small or with a simple name search. You may remember Chihae's presentation. There were Chihae was talking about alpha-beta unsaturated carbonyl compounds, and one of these compounds also shown on one of the slides was fulfural. So we can just make a small search for fulfural in the database, and you see once you start typing here in the name field, the system already suggests to you or tells you what is available, starting with and this process starts when you start to type actually. So then you just select it, or of course you can also write it to the end. You also have the possibility to do some other searches here, so you can search for the exact name, but you can also search for the partial name. So for example, you type in benzo, and then you will retrieve all compounds that contain in the name benzo. Okay, but here now we want to do a exact search, so we keep the option here, click at exact, just click the search button, and then the hit list shows up, and obviously we have fulfural in the database, and exactly one time. So you just click on the hit list on the molecule to get some further information, to come to the so-called compound information page. And this compound information page then shows to you, and Chihae already has shown some screenshots of that, shows to you all the IDs and names that are available or that come with that compound, causing ref number, and also the compound annotation. So this the use type, use function. So obviously fulfural is used as a flavor agent or as a sort of solvent. And Chihae mentioned that also that we link out, for example, to causing. So okay, so you can now browse the causing list, and also here the inventory, you should get directly to the entry in the causing list of fulfural to get some further information. Also very important then is this section here, the toxicity data, where all the toxicity studies that are stored along with it compound are available. So for example here in the O repeat dose, O repeat tox database, we have some chronic and some subchronic studies, and for example the mouse 90 days subchronic study, if you click on it, then you get some further information about data source, the inventory, okay, that was O repeat tox database, study quality, if it's assigned or not, and then further down you also get the information about the dose levels and the dose ranges. And if you click on one of these links here, then and I really have to apologize, but this is due to the relatively small screen here. You get to the dose effect tables. I'll make it a little bit smaller, and you have access to all the information that have been extracted from the toxicity studies. So you have the various dose groups here, then the assays in one column, and the effects that have been measured, and also the description of the effect. So, for example, here you have liver. This compound is reported to cause liver necrosis. We actually have some information about the liver effects of that compound. Also, if a numerical endpoint has been assigned to this compound or to this study, we show it here along with what is the reason or what is the effect that led to this numerical endpoint. So, obviously, in Chihae's presentation, Chihae already mentioned that these alpha-beta unsaturated compounds may cause some liver toxicity or steatosis, fibrosis. So what you can also do with the Cosmos database, you just go back to the search form again. We now clear the chemistry part of the search form and just go to a toxicity search. So we just have a look, you select an endpoint, for example, subchronic, and just want to see what kind of subchronic studies in the Cosmos database show some liver effects. So we go to Cite here in this drop-down menu, and all these drop-down menus here are basically dynamically adjusted depending on what kind of endpoints and study source you are selecting. And here you have also a filter or search function. So you just type liver and immediately all the liver entries here can be seen. And so we want to look for general effects in liver. So we just select liver, press add and close. And now we have added this query definition, this query filter here to the toxicity study filter. Again, we just press the search button to retrieve all the compounds that have some that show some liver effects in subchronic studies, and in total we retrieved 222 hits. The number of hits is always displayed at the top of the hit list. A hit list then is basically a list of 10 compounds, but of course you can click further to look at the next 10 compounds. It's just more convenient to browse, and in fact already on the second page we find some structures with alpha-beta unsaturated systems which show some effects in liver. You also see here in this studies column the number of studies, and this is already the filtered down number of studies. Only these studies that show some that are subchronic and show some liver effects. So probably these compounds have more than one study. So if we then just click, for example, on this compound here, again we have all the information of IDs and names, compound annotations. So this compound is used as a preservative, as an antimicrobial microbial agent. And if we again go to the toxicity data section, you then see, okay, toxicity data is filtered according to your search query because we restricted the search to subchronic studies that show liver effects. So just go here, okay, here's the subchronic study. So we have one 90 days rat study. Then again, if we go down, we can get some further information about the study. So here, the study completeness was assessed. So it's actually a GLP QA compliant study. And again, we have the different treatment groups and effect tables. If we click on it here, and in fact already here by 75 ppm, there's some liver inflammation reported for this compound. So again, I have to scroll around a bit. Also, sometimes we have some comments, sometimes the study provided some comments or some information that did not fit into one of our predefined form here, so we added them as comments when it was considered by our expert that is really relevant or important information. Okay, then you can also generate reports for your compound or export the molecule to process it further or use it in other applications. And now, just as a last thing, what I wanted to show to you is that with the Cosmos database and the query form, you can really start to, what we call a hypothesis-driven query. So actually you now see, okay, there is some data about alpha-beta unsaturated carbonyl compounds, and they show obviously some effects in liver, and that's the nice thing with this chemistry and toxicity query, that you can combine actually the both of them. So what you are doing is you go on the left-hand side, you go to the chemistry search, just say, okay, obviously these alpha-beta unsaturated systems has something to do with liver effects, and now I don't do an exact search because I want to retrieve all compounds that are available in the Cosmos database that display or that exhibit this structural feature. And on the other hand, I can now do a combination of the chemistry search with a toxicity search. So I just, for example, say now again, as an endpoint, I want to retrieve all subchronic studies, wrong one, sorry, or subchronic studies. Now I really want to focus on the OREP tox database as the study source, and again a very broad search for the site. So again, I just want to see some effects or some effects in liver. So I add this again as a filter, and now you see the combined filter, the chemistry search and the toxicity search. And final check, okay, I have clicked on partial, and now in total I retrieve now 5 hits. So that means all these compounds show this alpha-beta unsaturated system, but also have at least one study in one subchronic study in OREP tox database that records some liver findings or some liver effects. So, for example, if I click here on malic acid anhydride and have a look at what kind of toxicity data is available there. Okay, I searched subchronic rat study and got also clear from Gia's presentation that we have a lot of data for subchronic and for rat. And again, you see you can browse the all the findings and those groups. For example, really just a little bit hard. Oops. Right, yeah, here, this is what you mean. So let's see what kind of comment. So in this case, there's only the dose regimen is repeated. As I said before, so when there was some information that did not fit into our form here, but our experts, our toxicologists thought that this is really relevant and important information that was is entered here. Let me just see in one of the...
I hope maybe others. I was wondering where you have the information about control groups, if there were any. The control is actually considered as a little treatment related. They're all considered for control. So, but some studies, they don't, from my knowledge, whenever a toxicologist comes to me, they always say, oh, did it have the control group? Of course. So there are two ways to then. We have to give all the control data, count data, and concentration data. And you will require actually a toxicologist to look at that, okay, and evaluate it. If you have a control data and the dose group data, the dose group have to be compared to the control, each one, and then you have to run a test, either some kind of Foucault test or, statistical testing. So you could do it that way, or another way to do that is already take so there's already an aggregation in that sense, that some toxicologist, a person who decided that I took this value of dose 1 compared to the control, divided that, and there was a 10% increase in body weight. So I'm going to call it body weight gain or whatever, increase or decrease.
So
okay?
you can.
So there are two ways to do this. And this is why when you do it that way, you have to say, is this treatment related? Is this statistically significant? And that's why the qualifiers are there.
Where do we have that here?
Okay, do you need to clarify that or anything else, Christof?
No, not at all.
Or should we take any further questions?
Yeah.
Yeah, I'm just thinking, I am not a toxicologist, but I will be the user. I will be the user of these types of databases. And when I want to say, all right, I've looked at this data and I will try to do some modeling with this data, and then I did something, then always the end user will question the original data. And I won't have any justification to tell them what was done. If it wasn't specified that there was a control group or the control group was this and that or something like that, because I am not a toxicologist again, but always it seems the most important thing, because when they come to me, they always ask, or when I read a Russian journal paper for them, they always ask me to look at if there was a control group.
Mm-hmm.
So I'm just thinking how to make it clearer, but maybe Chihae's explanation should be put as something like a note there or something, that this was the way it was decided to do. Just a clarification for the user.
Thank you for that. Clearly, if there's something that isn't clear. Any other questions? Oh, start. I'll get down to you, Richard.
Catherine Marnie, Procter & Gamble. So a question and a request for you, Chihae. Your passion for this database is clear, so could I be mean and ask you, what are the plans to maintain and grow it?
Thank you. We have a one live slide that Mark is going to show, actually, because this is coming from the consortium, so it's proper that Mark shows. One last slide, Mark. Thank you for asking.
And whilst you're bringing that slide up, if I could just share my request, which is when you list the most common organs that you're seeing as affected in frequency order, could you also think about the low toxicity, no toxicity domain and include that in that list?
It's a very good suggestion. See, we keep learning how to actually present this data. Thank you.
Thank you. Richard Marchese Robinson, John Moores University. Thank you for a very interesting presentation. I just had two questions. So one is the Cosmos quality criteria. Are they described in any published work? Yes, I'm sorry. And the second question would be, is it possible to export the entire database, for example, as a SQL dump? And if so, are there any restrictions on how you can redistribute that data, etc.?
It's my fault that I haven't written a paper yet, so Mark is pushing me. It's actually written now. It will go in a Cosmos publication. Okay. The second thing is Mark is about to...
Thank you. Yes, It's Mark Cronin, and hopefully online you can hear the slide. Hear the slide? See the slide that's on the shown at the moment. It's, as I said in my preamble, it's clear we need to maintain this database, and we have clear plans to do that. The first thing will be that the repeat dose toxicity database will be available as a flat dump, so it'll be available, basically you can dump it straight out into an Excel file without restriction, so it's the complete database dump, sorry, yes. So the complete database in version 1 will be available. We're also maintaining the database through exchange of the data, so the repeat dose data are being donated to ToxerFDB and to HES, that's ToxerFDB from the US EPA and HES from the Japanese Ministry. And into the future, we can see that the Cosmos database is a flexible format for capturing data. And we also already have interest from a number of organizations, CIR, FDA in the US, Korean cosmetics industry, another cosmetics industry, in recording and being able to use this to share data. So the Cosmos database will still be available after the end of this year, and the plan is not to leave it as a static organism, but to encourage growth within it. So one of the things we would like to do, and we will be seeking, is, apart from those industries and agencies listed there, other partners that wish to come in, help us, donations of data, curation of data, harvesting of data. And clearly this can form the basis of future work, future projects. So we're committed to this in Liverpool. Molecular Networks and Altamira are committed to the continuing of the database, but also growth of the database. And that needs to be through data donation in this format. So does that address that particular comment?
Thank you very much, Mark.
Just lower it a bit, Richard.
Sorry.
I think. Yeah.
Thank you very much. Just one thing I wasn't entirely clear upon, again, coming back to my earlier question about licensing, in terms of exactly what the restrictions are. If, for example, I, as a QSAR modeler, downloaded the database dump, derived, say, a data set for a QSAR model, would I then be allowed to, put that on my own website or put it in the supporting information for a paper, etc.?
Yes, if you're as unwise to do that as you, but yes, clearly you'd have to acknowledge the source of the data, but yes.